Good morning, happy Thursday. Let's switch over to the main scene. Yes? Camera? Okay. Camera. Normally I have autofocus on. Yeah, autofocus is on. Oh, there it goes. Nope. Whoa, I took autofocus off. And that fixed it? Hold on. Hold on. Custom video. Wait, camera control, focus. Mew V, good morning. Okay, I won't question it. Programming is hard. Okay, so let's take a look at where we are again. We have, if we run, our game, we have the ability to move left and right now as our player. We can sort of move into the areas that we don't really want to move into, but we can get there. You wonder how a good deepfake network would be good at creating non-existent images of fruits. Haven't there been examples of that already? Like I figured they'd be pretty good at it, especially if they're just sitting still in an environment. I think it's mostly when you have to animate them interacting in reality that's when it. I think it's less about how good the network can be and how just much time it takes to make it. All right, so we need. Oh, and also we can create something like fire 3, which will spawn that and drop it down. I don't know. Imagine seeing it generate a red banana. I mean, it could, but I think that's only if you tell it that bananas could be red, right? I don't know. I've only played around with machine learning type stuff. Very, just a small amount. I made a bot that can play Pong using deep learning, and that is nowhere near the experience that they need to be able to judge creating deep fakes. Okay, so interesting. 10 goes there. I didn't think that I was allowing it to go outside of. Does 11 work? Oh, it does. Okay, so it's going across the entire screen. That's cute. I really wanted to start at 9. I stop at 9. Are you working on 12, fire 13? So fire 13 does drop it. So it drops it right outside the screen. Interesting, okay. That means this is continuing to display behind here? Maybe? Or it's across the entire screen that it's dropping, which is interesting. Well, we'll have to figure that out too. So let's add that to the polish list. Stop drops outside of the game, but still on the screen. Like in the instructions area. It does reject negative numbers, and if the number is too high, it rejects that too. It's just interesting. I think like if you go outside the U8 bounds, so if you do like a fire 256, that should reject it. So I need to just basically clamp it down to within like 0 to 9, essentially. Okay, so we have that. What's next? What are we doing today? Player slows down to a halt when not moving a key. Okay, so that means we need to add in some kind of friction as I'm moving left and right. Well, you gotta go. Well, thanks for stopping by and saying hello. Have a good day wherever you are. And Lord Mist, hello. Good morning. All right. Player physics. Player physics. So what I want to do is figure out what our horizontal movement is, and then also have our like a friction force. So we're gonna put that up here. The game seems to be going pretty well so far. Just only a small number of bugs. Alright, so we're going to do a 0.2 of an F32. Actually, a friction can just be an F32. Let's make this a 0.01, and let's just see if that's enough. For every update at the end of here, I want to now apply the friction. And so what friction means is whatever our x velocity is, we want to... Do I want to multiply by that amount, or do I want to just subtract that amount? I mean, either of them could be appropriate. I want to slow down by 1% each frame, or I want to like actually just apply that friction as a thing. You finally got a new graphics card. Ooh, nice. Which graphics card did you get? Let's try just applying this as a friction. So we'll just subtract it first and see how that feels. So if self.velocity.x, if this is less than 0.0, so if we're moving to the left, ooh, you got an RTX 2080 Super. That's the one I have here in this system. It's a good graphics card. I haven't done any of the cool like ray tracing stuff with it that it's supposed to be able to do. Like when I open up the NVIDIA stuff, it constantly says like, hey, do you want to try Minecraft in ray tracing mode? It's really nice. The only problem is that your UPS starts screaming when you run a benchmark. Oh, because it draws too much power. Oh no. All right. So if we want to do this, I want to now add our friction. So self.velocity plus 0. You tried Minecraft in RTX. It looks terrible. Oh, fascinating. Is it because the ray tracing is like too good almost for it? Like because the shadows become super realistic, therefore everything else is now no longer as realistic. It just doesn't fit the game and also doesn't look realistic. Okay, yeah. That is a very fascinating thing. It also looks too flat. Interesting. Yeah, I guess that really shows that if you're going to do ray tracing, you also have to do other graphic things to sort of match what that feel is going to be. It does feel like they did that for a gimmick, which, I mean, it's fine. Everything has the same brightness. Oh, interesting. Yeah, it is a gimmick. I've never done ray tracing myself. It's something that like would be cool to like look into. Maybe even just 2D ray tracing. Sure, there's shadows, but that's about it. Shadows and reflections are the two things that I'm aware of that ray tracing really helps out with. I guess like also you can use rays for collision detection also, or like what is going to collide. Okay, so they completely failed at the water. Inofficial shaders do that way better. I haven't played with shaders very much either. That's another thing I want to look at. Raven Legend 4066. Hello, good morning. Let me go ahead and make the chat readable. Problem is the RTX shaders are all expensive. All are expensive. All right, so now thinking about this, I don't want to just subtract by this because that's not going to look right. I want to like slow down by a slow amount. So actually I do want to multiply by this friction. So if I'm moving to the left, I want to subtract equal by whatever the velocity is times the friction. So self dot velocity times self dot friction, and that should slow me down to a certain degree. Now it's going to be getting me closer and closer to 0 until I eventually M0. $10 a month? What? Also, Raven Legend with a 50 cheer. Thank you so much for that cheer. Thank you, thank you, thank you. Unfortunately, I don't have any stuff. I haven't like made any things that like listen to those events yet, so I can't actually do anything on the screen. I know I could get like any of the other like sort of commercial bots and put them up, but I've been building these out myself. So that's going to be a future project we're going to work on. But thank you again for the cheer. All right, so you need to be a .x here, and then a .x, and then a self-friction. Okay, so that makes you all happy. So else if self.velocity.x is greater than 0.0, and then we can clamp this down by basically saying that if we're within like a certain amount, we'll just set ourselves to 0 to finally stop ourselves. We'll just sort of see how this feels. Self.velocity.x plus. So we're already moving negative. This should be a plus equals. This should be a minus equals. Self.velocity .x times self.friction. We also want to negative this. Can I just do that? I think that works. We'll find out. Let's try it right now. One drop, one score. Good job with that. Okay, so we are slowing down, but we still slow down really slowly. So I think I want to increase that number a little bit. Yeah, I've got sprites. I've been working a little bit closer with like those sprite systems and figuring out those. So the games look so much nicer now than just like simple squares. Now I didn't make these. Whoa, okay. So that was a little bit too fast. I want to actually go the opposite direction. That's This command works. Oh wait, you know what? I need to fix that. We changed it to be a space instead of a dash. You aren't slowing down. So I need to figure out. Let's go ahead and like fix that really quickly. In the game objects, where is that? In the main library, we create this. It is space. So save that. All right, that'll be perfect. But with that, can't you stand it between two spots so it's impossible to hit you? Potentially yes. I haven't like tested. We can increase the size of the scale of each of these things too. So we can play with it to balance it out. All right. That increases in speed. Okay. So that's not what I want. I want the ability to slow ourselves down. So I think I need to actually think this through. Oh, you missed really closely. Let's see. Interface, game objects. Let's go to our player physics here, and let's actually think about what this means. So we have our x velocity. I want to reduce our velocity. So I want to get the opposite of our velocity. So, okay, if we're moving to the left, let's get our exact velocity, but to the opposite. So we'll do let opposite velocity equals self dot velocity dot x times -1.0. Okay. And basically what we can do maybe is just say, hey, if we're not equal to 0. So if we're not exactly standing still, let's go ahead and get the opposite of what our velocity is. Let's then multiply this so that this is going to be like the speed decrease equals self dot velocity dot x times and then that's going to be our self dot friction. Okay. And then I want to increment that, so we don't need this else if anymore. Then I want to say self dot velocity dot x plus equals the speed decrease. I actually want this to be the opposite velocity. Times self dot friction, that gives us the speed decrease, and then we use the speed decrease to change the velocity. Okay, so let's try this. Every once in a while the window starts a little bit low down, so it looks like I fall through the floor, but okay, this is significantly better. It slowed me down, but it slows me down like almost stopping like right away. So if I increase our stop velocity to like 0.2, let's say, but I also increase our movement force to like 1.7, let's say. That's maybe a little bit too much. So let's reduce our friction down to like 1.0.19, 1.8. I like the stop, but I need the movement to be higher. So let's go to like 2.5. Okay, this isn't terrible. I get to stop exactly when I want to. It's not completely just stopping on a dime. It moves just a few pixels to the right or left. And I can move decently fast enough that I can avoid things. So now if I do like a fire like 5, I can, oh, I need to actually click back into here to avoid it. So if I do fire like 4, I can click over here and get out of the way in time. So there's, I think that's good. I think that's good speed then. And of course, those are things that we can tweak. So let's go ahead and take a look at our README. Our player slows down and comes to a halt when not moving the key down. That happens. The player can jump. Because those fires stick around on the ground, I need the ability to jump over them to avoid them. So, jumping is a thing. Now we have this velocity, and so we can jump up. We already see ourselves like starting up in the air and then falling down. So that's really just affecting ourselves by gravity. So if we have in our handle, let's move this into another function here. So we have our updates. Let's do like a handle input here. We know we need the context also. And then you can all move down into here. And what that means is that we'll call handle update inside of here. Handle input. What are you upset about? Oh, right. I don't actually want you to be in there. I want you to be in here. Wrong impl. Okay, so there you go with that. And then this is handle input. Pass it in that context. And semicolon, and we're good to go. Nothing else to change for us, so let's go ahead and implement. Here we have if we're pressing A or S for left and right. Let's also do a space for jump. So if input keyboard is key pressed, key code is space. Then what I really want to do is have a jump force. And let's make this a negative 5.0 and just see how that looks. When we jump, we also want to turn our affected by gravity back on to true. And that will start making us fall back down again. All right, let's try that. Now we're probably gonna be able to jump in the air because I don't have anything saying that we can't do that. That's maybe just a guess. That might be a little bit of a strong jump force. Just a thought. Would you add jump fatigue? So what do you mean by that? Do you mean like so that I can't constantly jump? So like I get tired and have to like stop jumping after a little while? You know, it's a good question. It's more like a game design question. And I don't know how that would affect the game. Because those flames stay around for a while, it's possible for especially if there's enough of you in chat playing, you could box me in. So if I don't have a jump, I wouldn't be able to go. If you jump simultaneously, the height would decrease. Ooh, interesting. So like my jump force would go down. It might be interesting. I think I'm going to not do that for right now. But then maybe play around with it. The other thing is I noticed I need to check, so if input is key pressed, and we cannot be affected by gravity. So let's actually create a function to sort of deal with this. So we're gonna do a function is jumping. We're going to return a boolean, and all we're going to do is return self dot affected by gravity. If we are affected by gravity, we'll say that we're jumping. Or actually, maybe let's change this to in air. If we're in the air, we're affected by gravity. If we're on the ground, our affected by gravity is going to be false. So really, this is just an abstraction to make this a little bit easier to reason about. So that way I can say, okay, if space is pressed and self dot in air. Actually, let's do this the opposite way. On ground. That way it's truthy. Then this will be a not. So if we're not affected by gravity, then allow ourselves to jump. And let's see how this ends up looking. Yeah, so this is what I was sort of like thinking about. This is maybe a little bit too low of a jump. So I didn't want to decrease the jump force. I need to increase the jump force. Let's make it like 15. Okay, a factor of 3 was too much. Yeah, I need to reduce that down by... So 5 was too little. 15 is way too high. Let's try... Let's try like maybe like 8. $12.5, you think? Well, this isn't too bad. So if I send a fire at like 5, yeah, I can jump over this. My actually horizontal movement is really fast. I might want to like reduce that down a little bit, just to make it a little bit easier to make it just a little bit easier to move back and forth. So move force, let's do this as like 2.0. I might need to reduce the friction amount. Let's make this a constant too. So friction is going to be 32. And let's do this like 0.15. We won't store you here or here. And friction will just be the constant. Okay. Let's try this. So if I do a fire 6 or fire 5, I can jump over it. It's pretty tough. I might want to give myself just a tiny bit higher jump. Jump force -8.5. I think that'll do it for now. We can obviously tweak these numbers. They're constants at the top of this file, so it should be pretty easy for us to like go in and tweak them until we get what looks right. All right, so the player can jump. The player can also stand on the ground. We've got that. The player cannot leave the arena. So this is a problem. I can currently just nope out and just say like, you know what? Good luck, everybody. I know you can't go negative numbers, so I'll just hang out there and win. That's clearly a problem. So let's fix that. Can we only shoot one column at a time? Do you have to enter the fire command 2 times if you want shot 2 and then 6 right after each other? Yes, you have to enter it multiple times. The reason why I was thinking about that is I want more people in chat interacting with it as opposed to like one person essentially winning the game for it. That's kind of what I'm going for, is like everybody working together to sort of like pin me in, as it were. So to sort of clamp down on what I need more than just the update here. Sorry, I need more than just the screen size. I also need to know what is the let's make the screen size not the screen size, but the arena size. So let's go to the. If I rename this, will you be upset with me? I'm allowed. Okay, so I've never actually tried that. I've never tried renaming traits. I'm renaming the properties coming in from traits. So what this means is in our main library, when we call update, here's our game object, and we're handing it the full screen size. What I really want to do is get the arena size. So the Y is going to be the same. So if we say something like 50.50, let's maybe do like 500.0, just to start off that with. And then the screen size dot 1. The Y is going to be the same, so we don't really care about that. Then we pass this in here as the arena size. Okay, so that's fine. Now for you, we have to figure out what this actual number is, which is going to be the screen size dot 0 minus however big the interface is. And we have this instruction width. Well, that's the title width. We want like the full. Oh no, that's the instruction width plus margin times 2. Even though you are coding in Rust, would the game become an exe file once finished? Yes, actually it does. So if we come down here to target, whenever I'm compiling and just like running those, even in debug mode, here is, where is it? Here it is. Here's the actual game executable. So it's an exe already. It's just an exe in debug mode. When I compile this for release mode, then the exe will be much nicer and smaller and faster. All right. Now interface. Do I actually have access to the size of that? Self.interface. I don't see that. Let's go ahead and add that into the interface. So we have instruction background, instruction width. Let's make this public. That way here, self.interface.instruction width, and then that should help me clamp down on the left and the right. They're going to come back to player physics, and so now we can trust this arena size. Okay, so what is that? How does it switch from Rust to exe? So I'm programming in Rust in this language. And then whenever you see me come down to here and I type in cargo run, what's that doing is it's taking all my source code, it's compiling it and turning it into an executable file and then launching that. I could take this into like multiple steps by running cargo build. That would create the executable file. So if I do that, that creates the executable file, but it doesn't launch it. I would then have to come down, find this, double click it. Actually, I can't do that in VS Code. I have to open this, reveal in File Explorer. Then I can double click it, which should run it. Maybe not. Maybe it's just quitting right away. Oh, is there some kind of, do I have an error? No. I'll have to figure out, what is causing that to... no, I have the resources in here. I'll have to figure out what's going on with you know, have I double clicked most of my games when I made them? I think almost all of them I've launched through the command line. Not running since code is not finished. It's possible that my code, the way I've written it, is it doesn't run unless I launch it through the command line. So if I cd out of here, go into target, debug, there's my get the streamer game, and if I run get the streamer game.exe, oh, the environment variable is not found. That's why it's failing. I need an environment variable set. I forgot that. I do have a .env. The .env is hidden from view, so I can't accidentally click it. But it's the way it works is .env looks in the directory that I'm coding in. So that's in right right around here. But the executable is in here, so I would need to move my .env over to here, if that makes sense. That's what the problem is. So that's something to keep in mind when I eventually publish this out. So let's actually add that into a list. This will be in Polish. So, like, create instructions for how to start the game. Maybe actually this is less Polish and more of like deploy. I also want to, I haven't done this very much, try to compile for Windows, compile for Mac, compile for Linux. That would be really interesting to see if I can actually do that. I know that like cross compilation is a thing, but I've run into trouble in the past when I've tried to, but it's been a while. Okay, so back to this. We're clamping ourselves down into the arena. Can I code Python, JavaScript, and/or C++? This is the last question. I'm asking to stop distractions. Oh, don't worry about that. I can code Python, although I haven't done it very much. I code JavaScript professionally during the day for my day job, and I have not touched C++. So it's less that I can't and more that I haven't, and I don't necessarily, unless a job requires me, I don't see myself starting to either. Okay, so I want to reduce myself in. So let's actually create a function for this. We'll create a function called stay in arena. So mute self. We're also going to take in the arena size. It's going to be a tuple of f32, f32. I can actually do this as extract this right here. So we're going to do arena width, arena height. We're not going to return anything. So one of these things we're already doing right here, which is this. If our location is below the floor, so if the bottom of our feet are below the floor, reset our location, set our velocity back to 0, and move up there. So let's go ahead and move this up there. And we call handle input. Let's also call self dot stay in arena. And we're going to pass in the arena. That. All right, so you're gonna be, we also need our location. Let's bring that in as well. Our location is a mutable reference to a rect. Okay. And then you call this arena.ones, that's the height. So we'll make you height, and we'll make you height. All right, so that's on the y-axis. We want like the left and the right now too. So if our location.x, we could do the left side first. So if the left side of us goes to the left edge, so like way over there, sort of like how you can see me go outside of the screen. So if our left edge is less than 0.0, then we want to first reset our location. So location.x equals 0.0. Let's kill our leftward velocity. So if we're moving to the left, so if self dot, actually, we probably don't need to kill the velocity. We stop pretty quickly afterwards. Let's just keep on resetting our location like this. So we'll just reset there. Else if. So if we're not past the left-hand side, then we're probably past the right-hand side. So if location at x plus the width, so that's location dot width. If that is greater than the arena width, then set the location.x is equal to the arena width minus location.width. Okay, that should keep us inside of the arena now. I need to go back, cd into streamer game and cargo run. Yep, I can't leave to the left, and I can't leave to the right. Perfect. So yep, I'm now stuck in here with all of you. So there's plenty of time for me to see things coming down, but if there's like, you know, if Twitch claims that I have 9 viewers right now, so if all 9 of you were to be firing at the same time, you could, it could be very challenging for me to try to avoid this, which I think could work. It does require you to spell correctly though. And it is unfortunately strict in like what it's looking for. So it is looking for #fire3. It ignores every command that it ignores everything that doesn't start with a hash. So, okay. We're now staying inside the arena. I don't know if that would be hitting me or not. Player cannot leave the arena. So, perfect. We've now implemented the player. What's next? Game is over after player is hit by an entity spawned by chat. So if you, for example, if I'm sitting here underneath 5 and you hit me with 5, then I want probably, I think a character walks through the item spawns. It does for right now because I haven't implemented collision detection for that. But we're gonna change that next. So as soon as I hit that, I want to put in like the game over screen. And I probably want to like stop listening to the chat messages. I'm not sure, but I want to like do the game over screen, or like congratulations, you got the streamer. So that's gonna be display the game over text. So when I get hit, so let's first implement collision detection for this. That's gonna be in player physics. But it's gonna be interesting because I need all of the other game objects besides myself to then see if I can collide with them. So right now what's happening is in our main library, we're iterating through all the game objects. And then we're just calling update on them. The player is in the game objects as well. What I need is the ability to pass in all the other game objects. And then pass that in for collision detection with the player. So this would be essentially once per frame, clone all the game objects, strip out the player, strip out, basically all I want is if we have active, if these are collidable, essentially. Let's add that in. So when we create a game object, we have a location, a draw system, a physics system, a birth time, a live for. Let's also make it collidable, which is a Boolean. Let's actually take that in as whether or not we are collidable. You're a Boolean. And then we'll store you down here. Let's make you public. So the idea is that the fire that we drop, that's going to be the only thing that's collidable. I really wish that Rust had a default that we can do. The only thing that I can do here is an option. Where I can say it's an option and then kind of sort of do a default. But I think it's going to be easier for us to just sort of handle it like this. So let's now walk through all the errors and fix them all. So we create the flame instruction. You're not collidable. So you're false. Next. Create the player. Are you collidable? No, false. This is creating a fire every time that you do the fire command. Are you collidable? Yes, that's going to be true. Okay, and that's all those errors. Let's then here in update, before we run update, let's get a clone of all the game objects, but with only the collidables. So we're gonna say collidable game objects equals self.gameObjects.clone. So we clone it first. We're probably gonna have to implement clone for this. That's gonna be interesting. We clone it first, then we have to turn it into an iterator. I'm okay with consuming it for this. Then I want to retain. Actually, it looks like I can just do a straight up retain here. Retain, we take a closure, which gives us a game object, and I want to return true if the game object is collidable. So game object dot isn't it collidable is part of this? And semicolon that. All right, so now this is going to complain because clone, Come on. No method named clone found for struct game. So like game object. The clone method exists, but the following trait bounds are not satisfied. Game object doesn't implement clone. So here we're going to go down a journey. We have to implement clone for game object. But if I do that, I now need to implement clone for all of these other things too. So this is going to be fun. Derive clone. And I think whenever you derive clone, you also have to derive copy. I think that's what you have to do. Okay, so then next is, let's see, what are you yelling at me about? The trait copy may not be implemented for this type because like this field doesn't implement copy. So now the draw system needs to implement copy. So derive clone copy. But now the sprite needs to implement clone and copy. That's interesting. I don't need to bring in the full sprite for this. Oh, this is fascinating. Okay, hold on. I might want to implement our own copy, our own clone for game object here. So here's what I'm thinking. We don't need a, when we clone this, we don't need a draw system. We don't need the physics system. I don't even care about the live for. We just really need its location, don't we? That's all we really care about. So let's impl clone for game object. And then we have to implement clone. So what we're gonna return is a new game object. And so this is the location. Okay. Location is gonna be self dot location dot clone. So clone that. That's fine. What's next? You kind of know what I want. All right. I guess you'll let me know. We're missing draw system. So draw system is going to be a none. What's next? Physics system is going to be a none. Birth time. I don't really care about that. Birth time. We could just put it in here. Self dot birth time, because that's just a number. Live for is, does live for have, oh, it's an option. So let's go ahead and make this a none. And then collidable. So collidable is self dot collidable. Okay, so this allows me to then come back to our main library, and we've cloned it. We get like sort of the stripped down version of the game object, and then we can retain only what we want to. We now get these collidable game objects, and we can pass this in to update by passing this in here. So collidable game objects. Now, of course, we need to go into game objects or update and say collidable game objects is a vector of game object The thing is, I only need to pass this in if it's the player. So every single frame I do need to do this calculation and grab this. But I only need to like pass this in when it's the player. And then I can give ownership to that player. Now I could pass in like just a reference to it. And that would make you happier. You become a reference to a vec of game objects. We could just say, you know what? You have like other game objects come in here. So collidable game objects, you need to be a reference to that, which means we need in our physics system. Is that the first thing we're doing? Yeah, physics system. So for our trait, we'll do collidable game objects is a reference to a vector of game object. You don't know what that is. Let's go ahead and bring that in. Game object. And then that means here's in library RS. Okay, so collidable game objects. Expected a reference to a vec. Hold on. What are you? You're nothing. You're a Boolean. So retain the reference to a game object. Oh, because I need to, so clone and then dot into iterator. Now retain is okay, hold on. Let's change this up a little bit. Your reference to game objects, which means I'm getting nothing back. So game objects collidable. So that's true or okay, so that's true or false. And that should be fine, right? We return true, we retain it in here. Self-tech game objects. This feels weird that it's okay, hold on. I want to see what the actual error message is. Just in case like VS Code is going a little bit weird. Okay, so you're still upset with this. All right, so expected struct standard vec found empty, found an empty reference, mismatch types on 144. So yeah, I am getting empty here. What is going on with that? So we have a vector for like self-tech game objects is a full vector. I'm cloning the vector of game object, so I get a full new one, and then I'm retaining only the ones that I care about. Is there another retain? Retain takes in a reference to this. Retains only elements specified with predicates. Huh, that's kind of what I'd still expect it to return the items inside of here. It's like we clone it, that gives us a vector, we call retain on it. We get the game object, and then I want to turn game object dot collidable, which is a boolean. But why are you empty? So if I do that, and let's say we don't implement this yet. Which means we need to go into the mod and remove that here. What are you upset about? Game object update. Compatible game objects. Let's remove you. All right, there we go. You're still saying that you're nothing. Let's go ahead and run this. And we should get those debug statements. So it's not just nothing. It's like a tuple of nothing. It's not a vector. If I do like fire 5, yeah, that doesn't appear in here. All right, so collidable elements. Self.gameObjects, which I'm doing the same thing here. I want to clone all those game objects. That's that first vector. We implement clone, and so let's say I don't even do a retain. Let's just say this. I do a clone. I now have a vec of game object. If I do this as like mutable in the two-step process, and then I do collidable game objects dot retain, oh, right, I forgot. Retain is it mutates. It doesn't return anything. So hold on. I know how to make it work this way. Instead of retain, we're going to use filter. And so then you need to be. Let's see. No method. So then I need to turn this into an iterator to take ownership of it. Then we filter true or false. If it returns true, the element is returned. So if you're collidable, it returns it, and we get that in there. And then we're going to collect you at the very end. And so that gives us, we need type here. So you're going to be a vec game object, like that. There we go. That's what we needed to do. So then, let's now sort of move backwards through this. Our player physics we need... we don't have all the game objects, so let's go. Super game object. And in update, that means in here, there's a game object. Let's go ahead and bring this in. So this is going to be collidable game objects is vec, and we really want this to be a reference to a vec game objects. Then in player physics, we bring in game objects, and in update, we want to take in collidable game objects. Okay, so save that. That makes you happy if we also need to come over to our item physics and do the exact same thing here. You're also going to take in a reference to this just because you're a trait. Okay, so that makes you happy, except we're not going to use you, so I can underscore you here. Then in game object, we need to pass you in. So that means we need in update, take in the collidable game objects, which is going to be a reference to a vec game object, and we pass you on through. Okay, so that makes you happy here, and then we're going to go into the library, and we have our collidable game objects. Let's pass in a reference to collidable game objects. There we go. So this should still run. I should still be able to move, jump, and all that stuff. Now we haven't implemented the collision detection. Sorry for cutting that off. Let's see. Player physics. So now I have all the other collidable game objects. Let's see if we collide with other, right? So function collide with. I wonder if this is like a check collision, really? Maybe like get colliding with. We're gonna have, this is gonna be self. We're also gonna have to get like the collidable game objects. Will I add a timer if an X minute streamer is not hit, then streamer wins appears? Yes, actually that's something I want to add in. Did I may have forgotten. Let's add that in here too. Streamer can win. Add a timer. If the streamer lives as long as the timer, display win message. There we go. Let's see. Get colliding with collidable game objects. You're going to be that the reference to the vector of game object, and we're going to return an option of, I guess you're going to have to be a reference to the game object. I could clone it. Like, that doesn't seem to be a problem with this. I could just do it, or I can just get a reference to it. which is basically just referencing out of here. And the only reason I'm doing option is that way we can have like none. We haven't collided with anything at all. So let's implement the to-do for this. And then we're going to essentially handle that down here. So here's my thought about this. We're gonna say if let some game object equals self dot get colliding with. We hand those collidable game objects. So if this is true, if we get a game object back, then we've collided with it. So for right now, I probably want just like a print line. We collided with a game object. I don't have like any names or anything else that we can do with that. So this is obviously going to have to be implemented later. We're going to have to store some interesting things. But let's go ahead and not worry about that right now. For our to-do. All right, how do I want to do this? We want to check to see if our location is overlapping with the game object's location. So we don't just need the collidable game objects. We need our location. So location, which is a reference to a rectangle. So if location dot, there overlaps, I believe. Check to see whether or not the rect overlaps another rect. Okay, so rect, and then the other one is going to be, we have to loop through all of these collidable game objects. So let's go ahead and do for other game object in the collidable game objects. I'm doing this so I can go an early exit. Okay, so for other game objects in this, if other game object dot overlaps dot location dot overlaps our location. So if our locations are overlapping, then I want to return early a sum, and it's going to be the other game object. If we get all the way down to here, I want to return a none. Like that. Now location is private, so let's go to game object and make location public. Lifetime mismatch. Oh, that's fun. Right, because game objects, having this be a reference here, let's actually not make this a reference, because that is problems. Let's actually just clone this. If we have performance problems, I'll deal with that. However, this happens at the end of the game, so it shouldn't really be that big of a deal. But now, okay, we get our game object. Self-colliding with, expected 2 arguments. We also need to pass in our location. No errors. Let's see if this works. All right, let's see if we get that message if we hit. So fire, what is it, 1? Hey, look at that! We collided with the game object. And if I move out of the way, yeah, okay, it's no longer happening. So that's really nice. So if I do like a fire 1 again, and I move into it, yeah, okay. So it's only happening when we're being hit by these game objects. So that's perfect. So what that means is we're gonna have our game. We're gonna have to do something inside of here. So display the game over text. We need to figure out how to do that. We need to display who won, so we need to like store that inside of the game object probably. And I also want to display who participated. So like everyone who dropped is like helped out. So okay, I think that's gonna be good for that. However, we're gonna have to do that next time because I'm out of time today. It is 8:25, which means I've got to get to work. It's a new sprint for me today at work, which also means lots of meetings in the mornings as we go through sprint planning. So let me take a look here. Bear Duda is streaming. Bear usually hangs out with us on stream. Let's go ahead and raid Bear. So I'm gonna go ahead and set that up. Raid Bear. Start stream. I don't know what Bear is working on today. He often does a lot of Rust programming. And he's been doing a lot of like Rust sort of library programming too. So that should be nice and fun. I'm gonna go ahead and switch over to my ending screen. Everybody, thanks a lot for watching. I'm doing these streams every single weekday morning at 7 a.m. Mountain Time until around 8:15 to 8:30 or so. But tomorrow morning is going to be slightly different. I'm thinking about having Friday mornings be an exploration stream. So instead of working on this game, we're going to just sort of explore around the Rust ecosystem. And I'm hoping that what I'm planning for tomorrow is going to be a lot of fun. So I guess I can tell you, I'm planning on taking a quick first look at the Bevy game engine. And so we'll take an hour and a half look at that. And then Sundays, I'm doing tutorial Sundays, and we're creating tutorials for Introduction to Rust. I know it's going to be hype. All right, so with that, have a great rest of your day, and I'll see you all next time. Bye.
Oh, I see.
So this is a field that's not even listed. Benefit end month. So this is an undocumented field. That's cool. Good morning. I don't know if you heard what I just said, but how was your stream? What were you working on this morning? Were you continuing your stuff from yesterday? I'm assuming. Benefit end month. String. Undocumented field. Go figure. And then we're just going to comment that out.